Which statement about elements in the D block of period 4 of the periodic table is correct? A. Chromium atoms have the electron configuration 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. B. Copper plus ions contain an incomplete 3D subshell. C. Iron 2 plus ions contain 3 unpaired electrons. D. Scandium forms ions with different oxidation states. So let's look at these individually first. Looking at A, chromium atoms have an electron configuration of 1s2, 2s2, 2p6, 3s2, 3p6, 3d5, 4s1. This statement is correct, and it's based on Hund's rule, which means that electrons want to fill up singularly before they pair up. So it's going to be more stable to have individually filled D subshells and one individually filled 4s subshell than it would be to pair this 4s electron with one of the 3D electrons. So this statement is true. Then looking at B, copper plus ions contain an incomplete 3D subshell. So if we do the electron configuration of copper first, that's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d10, and 4s1. And again, this is based on Hund's rule. We're deciding to pair the 3D before we pair the 4s. So looking at this, if we were going to make a copper plus ion, we would lose the 4s electrons first, and that would leave us with a complete 3D subshell. Therefore, B is not correct. Then looking at C, iron 2 plus ions contain 3 unpaired electrons. So again, let's write ion without the ions, so just iron on its own. That's going to be 1s2, 2s2, 2p6, 3s2, 3p6, 3d6, 4s2. So then if we made our ion 2 plus, so that would be losing these 4s electrons, both of them, so we get 3d6. And then drawing the D subshells, we can work out how many unpaired electrons we have. So we first singularly fill each D subshell, and then we've got 3d6, so we need to add 2 electrons to one of our subshells. So that's going to be, if we put it in this first one, and then we count how many unpaired electrons we have. So we have 4 unpaired electrons, so C is not correct because it should be 4. And finally, looking at D, so scandium doesn't have different ions of oxidation states because this is a trait of a transition metal and scandium doesn't count as a transition metal. This is because it doesn't lose electrons to form an ion with an incomplete D subshell. Instead, the most stable ion for scandium is scandium 3+, which doesn't have an incomplete D subshell. It just loses all of the 3D and 4s electrons to form this ion. So it doesn't have this classic trait of a transition metal, and therefore it doesn't count as one, so it won't form ions with different oxidation states because it can't. It only has one ion that's stable enough to be formed. So D is also incorrect, and therefore we write A in the answer box. So to get the mark for this question, you need to write A in the answer box provided.